Before I start, let me introduce myself. That might be the proper way to go there. My name is Dennis Ungaranu, and I am one of the many Mastercam AEs for MLC CAD Systems, and I'm based out of Houston, Texas. Over 20 years of manufacturing experience are, under my belt, and just ranging from different industries that I've worked with in the past. I have a background in kind of IT, computer stuff, and managing operations and quality control management for like ISO and things like that. Now with MLC CAD Systems, I'm bringing some of that knowledge and experience I've learned over the past over to you guys to improve your processes and benefit your companies on getting more efficient, with your workflows and your daily activities with Mastercam and manufacturing. Also, if you're ready to see some of the new stuff in Mastercam 2025, go ahead and throw a thumbs up there. So what I'm going to do as we get into this webinar is I'm going to number each one of these topics as I talk about. So what I'm going to do is show you 5 the new things in Mastercam 2025. Okay. What I'm going to do is I'm going to number them as I start. And the reason I'm going to do that is that we can then throw in a little timestamp and you could just jump into the topic that really you want to hear about, or I encourage you to just kind of watch through it all and, see and learn some of the new things, because there's quite a bit and they all kind of work with each other a little bit. So number 1 is uniform step downs, and that's pertaining to the Optirough toolpath. If you guys use Optirough in the past, it's a great toolpath. It's taking that dynamic toolpathing that dynamic milling in 2D uses and just kicking it up a notch, going into more of a 3D, three-dimensional environment and being able to rough out a lot of material efficiently and effectively with step downs and then incremental step ups, right? How could Optirough get any better? Well, it just did. So one of those things that you might have had to work around and kind of play around back and forth in your parameters window is those step downs. So we look at our cut parameters, and for step down amount, I have 125%. That's about 781 thousandths and a quarter of change there. And that value comes from the top of part. If we look at this model here as an example, that's the top of the part. And that's going to be each individual step down, 1, 2, 3, 4, 5, 6, so forth and so on. And that's going to equal that amount exactly. Not a problem, right? We've calculated how much of the flute length we want to take a cut on, and I'm good with that. Problem is when we get to that very last cut, or last step down, I should say, what happens with whatever's left over? So notice that amount, or that height, it's a lot shorter than the previous step downs. And that's just the way Mastercam's calculating from the very top of what you're trying to start with, of what you define the material, and that's your top, to the very maximum bottom that you're trying to cut, and giving you a 781 thousandths step down depth, and then left over with whatever. You could be left over with 25 or 50. And imagine that when you're looking at toolpaths like this, that'd be kind of hard to tell that you only have a 25 thou cut left over at the very end, right? You could totally absorb that easily if you were to kind of change that value and separate that amongst all the other amounts, right? So you go in and you maybe do some math and say, well, the amount of depth of cuts or step downs I have is this much, and then I got the height that I've set. Okay, I'm going to decrease that a little bit. All right, there you go. Right, but we keep having to go back into parameters to do that. Not anymore. Make it easy. Let's go to the new option here, and it's as simple as a checkbox. So we look at our tool and we determine that, yeah, 781 is about max that I want to step down with and engage with my flute length, right, on that type of tool, maybe based on material and all that. Well, what it does when you check this box is it essentially takes this amount, turns it into more of a max step down, a max step to cut. And what it'll do is it'll distribute the rest evenly from start to the very maximum bottom. So we'll go back to that same view that we had before and notice that last step down is equal to the previous step downs. Hence the word uniform step downs. Now that amount isn't 781. It's probably maybe 740, 750, could be somewhere in between. Does it really matter exactly? Well, if it matters, then don't turn it on. But it doesn't matter to me. I'd rather have consistency on all my depths, and that way my flute length is wearing out evenly, and that way my tool is lasting longer. That way when I'm hearing the hum of that tool running and removing material, because we machine with our ears. That's one guy that taught me that, is that we machine with our ears. And when we hear that same consistent hum, then we know everything is all right. So speaking of that last maximum depth, right? We could change that as well, right? And you could mess with your step downs. But what is that maximum depth? What is that final depth at? Well, that drives us into number 2. And the second thing that I'm going to show you for 2025 is one of the new things that they've improved on, so you can visually recognize what your heights are coming from your top of stock to your final depth and even clearance positions, right? If you remember in 2024, one of the new things were to all the drilling and hole making toolpaths were those colored planes. Now those colored planes were neat because you could quickly identify where your clearance plane is, where your retract plane goes, where your feed plane starts, where your top of stock is set, where your final depth is, and then if you're drilling, where your tip compensation is if you're drilling through the part. So it was quick and easy seeing those little graphical visual planes in different colors. And now they've introduced that into the milling toolpaths. Notice how I rotate my part, and since I'm on this page here, there's my maximum depth. So I'm looking at this value saying 40 thousandths of what? Well, I can see -40 from the bottom of the part, not the bottom of the fixture. Or this is not the bottom of my part. This is the top of the flat surface that gets bolted onto. So that's one quick visual representation, and we can work with other things, right? Like, for example, this is interactive. I can take this just like in the drilling ones and move it. So if I want my maximum depth to be the top of that surface, I can change that. Changes the value. I can click and it'll snap to certain points. I can go to minimum depth. I can do the same thing. I can see, well, my top of stock is here, and that's going to be right to the top of that surface. I can quickly see the start and finish depths for this part. And then the most important one, which I think is one of the most important, is your clearance plane, right? That's your rapid. That's where your tool, if anything's going to crash, it's going to crash at that high speed. And we don't want that. That's the worst thing for anything to happen, right? So we can visually see where our clearance plane is set. And I can bump that up a little bit. If I'm not feeling that confident or comfortable, no problem. I can move it, and I could also just set a number. Let's say we'll go 7.5 inches. Look at that. We got plenty of clearance from our top of stock. And those are the new visual enhancements or graphical visual planes in the milling toolpaths. And the benefit comes in other planes when you're working with other planes or kind of multi-axis, and you're doing the top of your part, front, side of your part, then definitely those planes come in handy to visually see if you've got your clearances set right from wherever your work offset is set, right? Okay. Number 3 is going to be something that's a little bit combined. All right. And that's going to be a hole recognition improvement to the solid models with auto feature detection, with improved automation on the process holes toolpath. If you haven't seen that or heard of that, we'll dive into that as well, which basically gets us faster hole programming by creating and setting up templates of your processes and then just recalling those processes to redo the same holes you do probably thousands and thousands of times per year. So let's jump into Mastercam and take a look at what I'm talking about. If you're familiar with 2023 and you go back to 2023, what they did is they took this model. Let's say they added a feature called find holes. So under model prep, they added this feature called find holes, right? And you could bring in a model like this that's got all these different solid features, like a counter bore for an M12 socket head bolt with a 1/2 inch through hole. But what height is that counter bore? What diameter is that counter bore? What else? What other holes are there? What are those sizes? Right? So you could say find holes, and it will find all those sizes out for you. It'll figure it out. A lot of times with these models, when they're brought in as an STP or parasolid, they won't have that feature history of how it was built. So however, whatever CAD system you're using, a lot of times it just comes in as a solid body, right? And it doesn't know that this hole is this size or counterbore and all that. Sometimes with SolidWorks, you could save it out as a solid part file and bring it in, and it'll retain some of that history. But most of the time, especially when you're dealing with STPs and parasolids, they don't have that information. That's what I kind of call a dummy model, because it just doesn't know anything. It's just a solid body, right? If you were to create all this in Mastercam, then you would have something like this. You'd see all your extrusions, and you'd see the history of how you created all these holes, right? So that's kind of what I did, right? Now, what they did in 2024 is they created this toolpath, and I'm not sure a lot of people even know about it, because a majority of the people I ask, they've said they've never heard of it. And that's a lot of things in 2024 that are new. And this one I'd say kind of slid under the radar a little bit. But it's this process hole toolpath. And I think it's a great toolpath. Only thing is that you had to have some kind of tribal knowledge or a little bit of inside scoop on how it worked. Okay. So the way process holes works is you have a process, right? I have a process, and I make a part, and I drilling, let's say a quarter 20 tap hole through on an aluminum plate, I have my process down for that. I use a spot drill, a drill, and a cut tap. Maybe it's a spiral tap or not, whatever it is. That's kind of my always go-to process. I'm sure you have the same process. If you're trying to do a half 13 hole through, you're probably using the same process. And your processes might change pertaining to the material. Maybe for one aluminum, you might use a cut tap, and maybe for stainless steel or other type of steel, you might jump into a roll tap, or you might use a thread mill, right? So you're going to keep that process, because if it worked last time, it's going to work the time next time, and the next time after that, and the next time after that. And you're going to keep doing it, because if that's your best process and your fastest process, then why change it up, right? So taking that information of creating processes, we can apply that to Mastercam, because we're always doing the same thing. So for example here, I got a part that has got 4 different type of holes. Notice I've named and I've grouped them together, and the name I've given will show up a little bit later. Okay. And I have an M12 socket head bolt through. So you do want to make sure you specify if it's through or not. But I have this process set where now for my hole segments, notice the information here. It figured out the counterbore size, the depth, and it split it up into different segments. Counterbore diameter 750 by 1/2 inch deep with a flat and another cylinder, which is my 1/2 inch drill through. That's 750 deep, but totaled out, it's 1.25 inches, right? That's the geometry of that hole. So in 2024, in order to get this information, if you've ever been to this page, probably seen it was blank. And without this information, you can't use process hole. Okay, so if it was blank, you'd have to go and do find holes, create, generate the find holes process, and then on top of that, you used to have to go to the solids manager here and do it from here and select from here when you're creating that toolpath. That is some tribal knowledge there, right? It was a little bit difficult, right? Just a little bit. Like I said, it worked, but you had to know to do that extra step. Not anymore. So just pretend I never showed you any of that. Just pretend that you never seen any of that. Whatever find holes is there for, you're going to use it for something else now. Because with process hole, you don't need it. Now you can just select any type of hole here, and notice that it'll extract that information. And when I go to my hole segments, it's pulled that information. Now it's all automatic, right? It's part of that auto feature recognition with models that don't have that history built in. So speaking of these toolpaths, I'd had to do 12 toolpaths for 4 different type of holes. Now, if I have another plate and my boss says, well, you got another plate to do here, it's got a little bit different pattern and, it's got the same holes or whatever. Well, I got to go back and reprogram all those 12 toolpaths. Now, I ain't going to do that. I don't know about you, but I'm not going to go back and reprogram those. Not the way I did the first time. What I'm going to do is I'm going to export all my toolpaths and import all my toolpaths and retouch all my geometry. And then you got to go to all your depths and then check your depths and make sure those are good. If that's your way of doing it, or you've kind of created a little more of a shortcut to do that, that's great. That saves you from spending that first, let's say it took me an hour to an hour and a half the first time around, to about 30 minutes. Not with process hole. If I've created that process and I saved that template file and named it, right? I can now select this counter bore, and I'll select all those holes because I'm holding Control Shift, and just pick out that template file. And that's going to be this template file. And what it does is, notice that grouped name that I was telling you about. Well, it figured out based on the geometry that that's my M12 socket head bolt process. And I hit OK. I just finished programming all those holes. And I can continue and just continue and just continue until I'm done with my entire part and reprogrammed it all in a matter of seconds. 30 seconds, if that. It's that fast. And it still gives us the flexibility of changing things around. Because you might say, well, Dennis, I want to change my half 13 process because this, for whatever reason, this, I don't have that tool, or I want to use a roll form tap instead, or I want a thread mill. That's fine. No problem. We can change things up. Just highlight all your processes and right click and just say explode process hole. And it splits up all those 12 toolpaths into individual toolpaths like you had originally in your template. I can right click and collapse, and there's all my 12 toolpaths. We can take it another step further, and we can right click and say, oh, let's sort by tool. Now we've sorted by tool, and we created a more optimized and efficient program, not having to do multiple tool changes back and forth, right? And I can go back and I can change my spot drill. I can select whatever changes I decided to make on the fly. I can go back and change those tools, which would be probably a roll tap size and your drill size for that roll tap, right? The powerful automation of Process Hole will save you tons of time and money, and it'll save you from repeating these processes back and forth. But you gotta have that prep work, right? Just like the chef in the kitchen doesn't show up at 5 o'clock right when dinner time is open and starts prepping those ingredients and cutting everything up ready for dinner, right? He shows up hours in advance, probably even early in the morning, to go shop for those fresh ingredients and then go back into the kitchen hours before to prep all those ingredients for dinner time. So that's what we're doing here. You got to prep by creating those templates, and you don't have to use a part. You could use just any model as long as your geometry is identical in size and type for what you typically always do, right? So that's pretty neat. I think those are very, very nice time-saving improvements to 2025. I'm super excited about that one. And number 4 is probably something you've asked many, many, many times over and over again, and you're finally getting it in 2025, which is to create a finished toolpath within 2D dynamic milling and area milling as well. Now you might ask, well, why would I want to do that? Well, that's because if you're familiar with dynamic milling or not, and you use it, you get these little vertical lines along the wall. And it's not always the best finish, right? You get this part that you machine, really nice finish on it, and then you get these little vertical scallops all along the wall. It's just because of that dynamic motion with that arc entry and exit. So now we can program a little bit quicker and save us from doing multiple toolpaths and operations now within the one. So let's take a look at a part here that's got both dynamic and a finished toolpath. So there's our dynamic motion. right? We see our entry arcs and exits. And then we see our finished toolpath along the wall. Notice on the left side in your toolpath manager, what do you have? One single toolpath. Before, you would have two. You'd have your dynamic roughing toolpath and then a contour toolpath, right? So now we're also consolidating the amount of toolpaths we have in this toolpath operation. There's one guy called me about 2-3 months ago, and he goes, "Hey Dennis, I'm using that dynamic toolpath, and is there a way to go back and rerun the walls? Because it leaves these little vertical lines, along it. It doesn't look that great." And I said, "Well, sir, if you would have called me about 2 to 3 months later, answer would be yes. But at this time, the answer is no." So that's because it's in 2024, they didn't have it, but now in 2025, they do. So he was, also coming back to me and saying, man, it's just, so I'm just trying to find a lazy way of doing it, to be honest. And I'm like, hey, you know what? I get it. We're always trying to find the lazy ways to do things with Mastercam and all this, right? We're always trying to find less clicks and ways to have to go through less dialog boxes and just get straight to the outcome that we want quicker and faster, right? Being more efficient. So I totally get it. We can all be lazy in that aspect and benefit from it. So let's look at the parameters here. And one thing that we're going to look at is the cut parameters. And we're going to see if anything changed on this page. Can you guys guess what changes are on this page? Anybody? All right. That's a trick question. Sort of. Nothing changed as far as the values and the parameters you have, except the values that you're going to enter. You're not going to leave stock anymore if you're going to finish with this toolpath, right? So, sorry about that, guys. I know it's a little dirty trick coming from me, but that's all right, because this one you're going to be happy with. Notice we got the finished passes here. Okay, we click on finished passes, and now that stock to leave amount along the wall gets entered here, because we're going to leave that spacing amount. Of course, make sure that's enabled, because if not, it'll be grayed out. But we got a number of passes that we can go and use, and spacing amount that we'll leave before the finish pass, and spring passes, and feed rate overrides, and spindle speed overrides. We have the option of machine finish passes at the final depth if you're taking multiple depth of cuts. We got a minimize burial option, which we'll come back to. In a cutting method, climb or conventional, and our typical compensation types. Keep in mind, what's also nice is that with contour, you have to worry about that green arrow. Where's it at? Which direction is it going? So that way, if you're trying to climb cut, make sure you got your comp on the right side of your chain, or I should say on the correct side of your chain, right? So you don't have to worry about that here. If you're going to finish, just hit climb and it'll figure it out automatically on its own. Below the finish passes, you have a little expansion there, and that's your typical lead in, lead out options. Nothing different here. All it is these just pertain to your finish pass only. It has nothing to do with your roughing. But let's take a look real quick at what this looks like. So I like this part. Looks like it's roughing and finishing everything. Very nice. Coming around that bolt. All that material's removed. Those pockets are all cleaned up. And I want to see if I can speed this up, right? I'm going to create I want to be more efficient, right? Faster. So I'm going to go to the tool and I'll say, well, I got a 3/16 flat end mill is what I'm using, but I got a 1/4 inch 5 flute flat end mill that I could use. That gives me a little bit larger step overs. Okay, I'm good with that. Let's try that. We'll hit OK. We'll let this thing regenerate. And then we'll come back and see how that looks like. Does anybody see anything different? I see something different. I noticed that there's a couple lines going around this area, but my dynamic roughing stops right here and comes back. Oh, that's not that good. That's not that good, but that's all right. Mastercam's got you covered, okay, because you don't have to worry about that. That's where that minimize burial option comes in play. But also, Mastercam has defaulted that option on so that this can't occur unless you turn it off specifically. But anytime you use that toolpath, it'll always be by default turned on. And what's happening here is that you basically have unroughed material here in this portion, and you have two finish passes, and at least your very first finish pass going in full width of that tool. That's full engagement. Now, if you're running high feeds and speeds using that dynamic motion, and your finish pass is probably running pretty similar high feeds and speeds because it's only removing 20 thou. Well, now when it comes into that material that's going to be full width, that's kind of an unsafe condition. We could have our tool get clogged up and overheat. We could have the tool chip or break, and we could possibly maybe get that material or the part to shift on us, and that's not very good, right? So Mastercam has thought of that and included in the finish pass that option, okay? So we'll turn that on and regenerate, and notice now when I zoom in, this area has no more finish passes. We can take a look at the finish pass, comes up around where it gets roughed, changes direction, and continues finishing the other sides of the wall. Okay, so worst case scenario here, we have a part that's got unremoved material. It's not unfinished yet, and we could either create another tool path for that or just revert back to that smaller tool to be able to rough and finish all areas of that pocket. So we could simply catch that and verify and see that that material hasn't been removed. But another thing to consider is that the safety of this tool path is because the finished tool path and the finishing chain and toolpath is able to see what the dynamic roughing left over, right? And what the dynamic toolpath is doing. Now, back in 2024, when you had the two toolpaths separated, the contour would not be able to distinguish what the dynamic toolpath did or didn't. And essentially, you could have still ran into that same situation unknowingly if you didn't run your verify or if you didn't visually check for that, right? So that's a benefit here, is that it's automatically saving you from potential hazards like that. All right, well, I know I've asked for that before, and now we finally got it. So I hope everyone's happy with getting that finish option there in the dynamic milling and area milling as well. So the fifth and final 2025 feature that I'm going to be showing you is 3-axis deburr. Okay. Now this is an add-on. It's an add-in that you have to get for your 2D mill, 3D mill, or router licenses. Okay. If you have a multi-axis license, then you already have the Deburr toolpath. So this one is pretty much irrelevant to you at this time because you have the latest and greatest license that gives you the option for Deburr and gives you option for even 5-axis and other capabilities to break the edges of a part. So if you don't have that multi-axis level license, which, not everybody needs it right away, and not everybody can afford that level of license or want to spend that much money for just one single toolpath, well, now you can have the benefits of the automatic feature recognition of your part geometry and the creation of automatic edge breaking toolpaths for your part while it's in the machine. So it's taking this Deburr toolpath, but it locks it in a 3-axis environment because you don't need it for multi-axis anyways, or else you would have a multi-axis license. But 2D, 3D milling licenses and router licenses are all in a 3-axis environment anyways. So typically you would see something like this. This would be your like a 5-axis Deburr toolpath motion. I usually will run kind of a quick back plot to show you what I'm talking about. But that's okay. We don't need to have that 5-axis capability to use the new 3-axis Deburr for even a part like this. So I'm going to delete that toolpath. And we're going to go find out where that 3-axis Deburr toolpath is hidden. Again, if you have it as an add-in, you'll have it available in your 3D group for Deburr 3-axis. And I'll show you how quick this is. You probably won't believe me. I'll hit that lollipop cutter, and maybe instead of hitting OK, we'll go back and we'll hit a cut pattern to actually select the material and the part, and then just select their entire part. Now I can hit the green check mark, and that's it. It's done. Once it's regenerated, then it's going to spit out the toolpath, and it's complete. It's that quick and easy. I just deburred the entire part. So I can run my verify. And before I run verify, it might help if I actually select my stock model here. So I'll go ahead and run my stock model and hit verify again. And I can just hit play once it appears and go ahead and check all my tool motion and check all my edges and make sure that they've all been addressed and all been deburred. Looks good to me. And the other benefit of this toolpath is doing things like this, where kind of like model chamfer toolpath does, it's able to know when to stop here so it doesn't collide with the wall. Okay. So great toolpath. Like I said, it's that quick on being able to break all the edges, but I'm going to slow it down a little bit for you, and we'll go back and take a look on how I did that. So I'll delete it just so you don't say, Dennis, you got tricks up your sleeve. No tricks. I actually even went too fast, faster than myself, and hit OK before I even selected the geometry. So first things first, right? You got to hit a tool. Okay. Now this works with 3 different tools. It's either a full radius ball end mill or a lollipop cutter, such as this one, which is nice because if you use a lollipop cutter, this toolpath will actually go through a hole and undercut and break the edge from the bottom side of the hole as well. So it saves you from having to flip the part in certain, situations. So go ahead and I'll select that one. The other type of tool you can use is a tapered end mill, but it has to be a full radius tip. So a full radius ball tapered end mill. Those 3 types of tools will work with this toolpath. And like I said, I just went to cut pattern went to my machining geometries, and selected my part. All I did was just unhide, or hide, I should say, more or less, my fixture so it's not in the way when I select my part. And now it's looking from the top down and looking at where all the sharp edges are and what needs to be broken. This is the amount that it's going to break, 20 thousandths. It's going to maintain a width or a depth, however you want. And if you want to exclude certain edges, let's say you do have sharp edges, or you have edges that you want to break a larger or smaller amount of, you can exclude them. Or you can also add to, so you can define specific edges. I want to just auto detect the entire part. My print says break all edges, 10 to 40 thou. So I went with 20. Somewhere in the middle there. Still leaves me a little room for more if I need to. You also have the overlap option, just like in a closed contour. You can overlap those closed chains. And if you do have an open chain, it'll extend the entry and the exit of that chain. That's about it. You can trim some corners, or you can relieve the corners. And you have your climb conventional. For tool axis control, the only thing that you need to worry about is your clearances. That's your holder, your shank, and shoulder. Okay, it'll maintain those clearances. Linking parameters is your entry, exit moves. And then you do have option to replace rapid with feed rates instead. Hit the OK, and there's your toolpaths. So you can come back here if you wanted to shorten up your clearances, you can, and optimize this a little bit. Otherwise, if this is just the one part, send this to the machine, send it to your operator, hit the go button. 10 minutes later, you got a completed part, send it to quality control, and you're done. You don't have to sit there by hand and manually try to break the edges, trying to get consistent chamfers or edge breaks around your holes and your pockets and all that. And hopefully you don't miss one, right? So that's the benefit of just keeping it all in the machine and working with your solid geometry that you've already started and programmed off of anyways, right? So those are those 5 things that I showed you that I wanted to show you in Mastercam 2025. There are more things that have come out, so please take a look at some of the other videos that we will be releasing with some of the other new things in 2025. And I hope you enjoyed seeing some of the new things and it was beneficial to you, and you can take that and improve some of your processes back at your work and your job.